Ever wondered how your Netflix recommendations get so eerily accurate, or how a self-driving car knows when to stop at a red light? This magic is largely attributed to deep networks. Deep networks, a type of artificial neural network, have multiple layers between the input and output layer. These layers help process complex data inputs, transforming them into something digestible for intelligent systems to work with. So, how do we train these deep networks to perform these amazing tasks? Stay tuned to find out. Training a deep network involves teaching it to make accurate predictions, and there are a few key steps involved in this process. The first step is data collection and pre-processing. This is akin to gathering the raw materials for our learning process. We collect relevant data and then pre-process it to make it suitable for our network. Pre-processing may involve tasks like normalization, handling missing data, or encoding categorical variables. Next, we define the network architecture. Think of it as designing the layout of our factory. We specify the number of layers in our network, the number of nodes in each layer, and the type of activation functions we will use. Once our architecture is in place, we initialize the weights. These weights are like the initial settings of our machinery. At this stage, they are set randomly, and our goal is to adjust these weights to minimize our error. Then comes the forward pass. We feed our pre-processed data into our network. Each layer performs its calculations and passes the result forward, hence the name. The loss function is then calculated. It quantifies how far off our predictions are from the true values. Finally, we perform the backward pass. Here we use a method called gradient descent to adjust our weights based on the calculated loss. It's like fine-tuning our machinery based on the feedback we get. The result? A trained deep network that can accurately process and interpret complex data. So why do we need to train deep networks? Well, the answer to this question lies in the heart of what makes deep learning so powerful. You see, training is the process that allows deep networks to learn from data and make accurate predictions. It's like teaching a child to recognize shapes or colors. With each training session, the network gets better and better at recognizing patterns in the data. Now let's take this a step further. The importance of training deep networks extends far beyond making accurate predictions. It opens up the possibilities for applying deep learning in fields like healthcare, finance, and even autonomous vehicles. Imagine a world where doctors can predict diseases before they manifest, or financial analysts can predict market trends with pinpoint accuracy. All of this is made possible by training deep networks. And that's why we train deep networks. Training deep networks is the key to unlocking the potential of artificial intelligence. Let's recap what we've learned today. We've delved into the intriguing world of deep networks, a cornerstone of modern artificial intelligence. These are powerful tools designed to mimic the human brain, capable of learning from vast amounts of data and making predictions with astonishing accuracy. Deep networks consist of multiple layers of nodes, each one responsible for understanding a different aspect of the data. The magic lies in their ability to identify patterns and relationships that might remain hidden to the human eye. It's like peeling back the layers of an onion, each one revealing more depth and detail. But these networks aren't born with this knowledge. They have to be trained. Training a deep network is a bit like teaching a child to recognize shapes or colors. You present it with a set of data, let it make predictions, and then correct it when it's wrong. Over time, the network learns to make more accurate predictions, honing its skills through a process of trial and error. This training process is crucial. Without it, a deep network is like a car without an engine. It might look impressive, but it can't actually do anything. Training gives deep networks the power to learn, adapt, and improve, turning them from static structures into dynamic learning machines. So why is all of this important? Well, as we increasingly rely on data to make decisions, the ability to extract meaningful insights from that data becomes more valuable. Deep networks are the key to unlocking these insights, transforming raw data into actionable knowledge. Whether it's predicting the stock market, diagnosing diseases, or developing autonomous vehicles, deep networks are reshaping the world as we know it. And as the volume of data continues to explode, their importance is only going to grow. Remember, as the world becomes more data-driven, the importance of understanding and training deep networks only continues to grow. Take a step towards the future and keep exploring the fascinating world of deep networks.